Hello everyone. In this video, we will compare two different search algorithms, linear search and binary search. We will provide the visual comparisons between these two algorithms and we will also discuss their implementation in Python. Finally, we will compare these two algorithms in terms of their time complexity and space complexity. Search algorithms are fundamental techniques that are used to locate specific data within collections like arrays, lists, or databases. These have many applications, for example, finding contacts in your phone or locating files on your computer. Let's look at the first search algorithm, which is linear search. It is a simple sequential approach, and to demonstrate this algorithm, we will use this example where we try to find the index corresponding to number 19 in the given array. So this array has 5 elements, and in Python, like many other languages, the index starts from 0. So we will start from the first index and we'll ask this question, is it number 19? Is the element that the array has at index 0 is 19? We ask this question. If it is, then we have found the solution. We can return 0 as the index. Otherwise, we move on to the next index and we ask the same question again and check again, and we continue until we find the correct index. So here we have found the number 19, and the answer or the return value for this algorithm will be the corresponding index, that is 3. Binary search works a little bit differently. It uses a divide and conquer methodology. Again, we will use the same example to demonstrate how binary search works. Here we will start with the leftmost and rightmost index, and we will compute the index in the middle, and we'll ask these questions. So the first question is that we want to check, is it the correct value or the target value? If the answer is yes, then we can return the index. If it is no, we will ask another question. So that is, if it is less than 19. If it is less than 19, we will update the lower bound or the lower index value. If it is greater than 19, we will update the upper bound or the higher index value. And then once we have this, we will do the same thing. We'll compute the middle index value, and in this case the left index value is the middle index value as well. That's where we will start asking the question again. And the good thing about this is that we have now discarded half of the array. So now we have to worry only about the next half of the array, and we will continue like this until we find the correct answer. So in this case, we ask the question again, is it 19? Luckily, yes, that's the same as the target value. So the answer that we will return is 3. So in this case, in 2 iterations, we have found the solution. How it works? So linear search, it examines each element sequentially from the beginning until we find the target or reach to the end of the array. And if we don't find the answer, we will simply return null value or -1 to indicate that the element did not exist in the array. So that's the code for the linear search. So that's the function definitions. The argument it takes is the input array and the target value that we are trying to find. And we simply loop the array from the start of the index. So we start checking whether that value at that certain index is the target value. If it is, we'll return the corresponding index, and if it is not, we will say -1 or none, indicating that the index does not exist or the value does not exist and we didn't find the correct index. Some characteristics of the linear search, that it works with both sorted and unsorted data, and that's the key advantage of using linear search. And you will see in the coming slide that there's a major restriction for the binary search, that the array elements needs to be sorted first in order for the binary search to work efficiently. It's simple to implement and understand. We start from the first index and then start comparing and stop wherever we find the value. Time complexity is ON. So this is proportional to data size because we start looking at each item individually and compare whether it matches the target value, and that's why the time complexity is ON. The space complexity is O1, that is constant space, because we are not creating any new data in this array, so the space complexity remains constant. On the other hand, binary search requires a sorted collection, but it delivers dramatically better performance. So that is the advantage, that the performance or the speed of this algorithm for large data set is exponentially faster. But the only drawback or bottleneck of this algorithm is that the data itself needs to be sorted before we apply the binary search algorithm. So the binary search algorithm, so this is the function definition. Again, it takes the array as input and the target value that we are trying to find. And we start with the left and right indices, and then we continue checking everything in a loop. So we compute the middle index value, and that is left plus right, and we do the integer division. Then we check whether that item in corresponding to this mid index is equal to our target value. If it is, then we return the mid value. If not, we ask another question whether that value is smaller than the target. In that case, we will update the left index value and we will increase it by mid plus 1. And if not, then we will update the right index value. And we continue this loop, and once we come out of this loop, it means that we haven't found the correct index, or the element does not exist within the array, so we return -1 or none. So binary search eliminates half of the remaining elements at each step, and that's what we saw in the previous examples, the visualizations as well as in the code. You could see that, and because of that, it is exponentially faster than linear search. Especially for large data sets, its time complexity is O log n, which is much faster than ON, and its space complexity remains the constant space regardless of the input size, that is O1. So both linear search and binary search have the same space complexity, but the time complexity is much better in case of binary search. So this was all about the search algorithm. In the next video, we will try to show you through Python code how we can apply binary search to different problems. Thanks for watching, and see you all in the next video.